and 5 minutes after, figure we could get started on intros, since that'll take a minute or two, and give people until maybe 10 after, and then we'll get started on the presentation. So everybody, welcome to the cadCAD call. Oh, my video turned off somehow. Let's see, maybe my internet turned it off. Yep, okay, not working. Yeah, so welcome to the cadCAD community call, hosted on the first Wednesday of every month. This month is October already somehow. Not sure when that happened, but yeah, so we'll just get started with a few intros from everyone, BK and Chakra. Hello, Chakra, and Angela and Daniel. And then we will jump into the presentation from Daniel on reinforcement learning in cadCAD agents. So I can start with the intros. So my name's Peter, and I have been in and around the cadCAD community for like probably 6 months now, although I really don't do much work in cadCAD, which is kind of funny. But I actually know a good amount, or I would say I know a lot about how cadCAD works, and I think it's really exciting, and using it for all of its modeling purposes, and I'm really excited about token engineering in general. So have been pretty active in between the TE Commons and the TE Academy with Angela, helping run some of the educational programs, and also chipping in at Block.Science a little bit too. So really excited about token engineering. I think this agent topic is really cool. Like I said, I've only heard people talk about using reinforcement learning in agents. I've never actually seen it done, so I'm really excited for the presentation. And yeah, I will pass it on to BK. And just give like a quick background of maybe how you got into token engineering or what you're doing in the space, and say hi.
Okay, yeah, sure. Yeah, my background's in electronics and data science, and I got into Web3 by knowing Longtail Financial. And right now I'm on a journey to be a token engineer. I do simulations on cadCAD. I'm learning Token Spice for like agent-based simulation for token economies. And yeah, that's my intro. I'll pass it to Berlin.
Hello, hi. I'm Matt Barlin, lead systems engineer at Block.Science. So just quite a bit of cadCAD modeling over the years. So I am looking forward to your talk and see how you're applying reinforcement learning into agents in cadCAD.
Massively underrating Berlin. Done a bit of cadCAD simulations. Okay.
cadCAD modeling for a few years. That's
for a few years, and you have
else.
pretty much built it together with the folks at Block.Science, right?
Yes. Yeah.
No pressure, Daniel.
Yeah, I think I can claim like the first cadCAD runs like that were actually used.
Okay. Thanks for clarification. You can choose who goes next, right?
Yes, I will choose YGG. Hey, Sean.
Hey, Barlin, thanks. Hey, guys, I'm just in a kind of another call, or someone beside me is on a call, so I think I'll pass it on for now. I'll pass it over to Austin.
My background is in physics, and I dabbled in reinforcement learning a little bit, because we were looking into how we could use that to find problems that are faster on the quantum annealer. But I haven't used cadCAD much yet, so looking forward to how they can both integrate together. Chakra, have you gone?
Hey, hi. I'm Chakra. Uh, I am a product manager. I've been working in crypto since 2018, and currently, I'm learning some data science stuff, and I came across cadCAD. So I'm excited to learn about token engineering here. Yeah.
And pass it to Angela.
I'm Angela. Hello. I kicked off Token Engineering Community in 2018. Now founded TE Academy last year. There, I had the pleasure to meet Daniel, and I'm pretty excited what you are going to present here. Looking forward. And I pass it on to Danilo. Hello.
Hey.
Brief introduction round.
So hi everyone, I'm Danilo, research engineer at Block.Science, atmospheric physicist for some years, and now I've turned it from studying climate change to study economic change. And yeah, nice to meet you all, guys.
Hey, Danilo. Cool. So then I guess that leaves us with Daniel.
Yeah, I think that's on me now. So first of all, thank you very much, all you for attending here, and really nice to meet you and to see you again, some of you, because we have been colleagues in the previous stage of the token engineering research group. As you may know, I'm Daniel. I'm working for bloX.move as product and business developer now, and my background is mainly in engineering. I started as mechanical engineering, and then life brought me to different paths: computer science, artificial intelligence, and I landed into the crypto world a couple of years ago. And especially with cadCAD, I started more or less 1 year ago as a hobby, and in the last 6 months, while I landed also in bloX.move, the company I'm working for, we decided to participate in the research group here with Angela and with other colleagues. And yeah, we like it. I think the experience were really nice for both sides, and the insights, of course, that we get from it. And here we are. And fortunately, in the last months, our company has other requirements. We have been focused a little bit more on the development of our core platform. But of course, these cadCAD simulations and token engineering is something that is still in mind, and we continue developing in. So I don't know if there is someone new in the call that wants to introduce himself.
Yeah, looks like Octopus just jumped in.
Yeah.
Octopus, we're just doing a quick round of intros, background, and saying hi.
Oh.
If you're able to chime in. All good if not. Cool. Well, then, yeah, let's get started. Save as much time as we can for the juicy topic.
As you want.
Yeah.
As you want. I'm going to present my actual company, and I'm going to present the work in artificial intelligence. I host a PhD in artificial intelligence and multi-agent, so I can be talking about this topic for several hours. So please stop me if it is too much, or if it's too technical, or if I'm explaining really wrong. It's also a possibility. Okay, so I just share my screen. Let me know if you're able to see it. Then we can start.
Yep, all set.
Okay, and here comes the presentation. Just to confirm.
Yes, got it.
Okay. So as I said, I'm working for bloX.move. We were part of the Token Engineering Academy research group. The date is October. That doesn't mean that we are actively participating until October. We were actively participating until the start of the summer. And since then, we have been following the latest advances and so on, and developing more our infrastructure in-house. But we are unfortunately not active. what I'm going to present today is basically the output of our past research and of course the latest advances that we have. However, I'm going to start with the presentation of the company with a little bit to understand why this thing is interesting for us and why are we putting resources here. I'm going to make an introduction in artificial intelligence at a high level. I'm not going to go too technical here, but of course I'm open for questions and we can discuss anything. And after that, I'm going just to jump directly into the cadCAD and the reinforcement learning ecosystem and how to integrate these two technologies here. And at the end, I will present some conclusions, potential work, future work, and open to discussion. As we are not many people here today, in order to make it more dynamic, I'm open to questions at any point. I think it's difficult if a lot of people is joining the call and interrupting, but as we are not that many, if anyone has some questions, please just stop me and we can make a pause and solve this issue and continue. Okay, so let's start with bloX.move. What is bloX.move? The platform that I'm working for, the platform that we are developing, is basically blockchain platform for decentralized mobility. That means that the problem that we want to solve is the integration of different mobility providers and make it easy to the user to be able to integrate both of them and to be able to operate with both of them. This is in terms of all-in journeys. That means when I want to travel from A to B, I only need just one ticket. For example, I'm traveling from Spain to Germany, and of course I need to take a plane. I need to take probably some trains, S1, U1, metro, or rent a taxi, scooter, or wherever. And our vision is that nowadays it's really complicated to do that because you need to contact the airline, then you arrive in a new city, probably you need to download a new app, you need to register in this app. This app only works for the public transportation there, which is buses, let's say, and after that the bus station is 1 kilometer from your hotel, so you need to take like bicycle, scooter, or wherever for what you need an extra app. And at the end this is a bit messy, and for people that is actively traveling, it's a little bit chaos. So what we want to do is integrate all these services only into one platform. I'm not saying only into one application, be careful with that, only into one platform that allows this service to be kind of decentralized, meaning that mobility provider A can offer in his app, of course, all his assets, but also can offer the assets from mobility provider B. That means that if I am used to work and I'm registered in one specific application, in this application I'm going to be able to rent, to see, of course, and to rent all the services from mobility provider A, B, and C, meaning cars, scooters, bicycles, and so on. Of course, the platform takes in charge of the connections, both B2B, and B2C. That means the interconnections of these companies, because when I rent a service through the application of a third party, a fee needs to be paid, and so on, but this is working in the backend. This is a little bit our vision, and the way we are doing it is through these kind of connections and basically putting the focus on identification, verification, offering, signing transactions, verifying verifiable credentials, and payment. That means that any asset or any user that wants to interact with our platform should first register and should be verified. The choosing offering means that we have an aggregator service that is able to read all the relevant information with regard to the assets offered. So this is the way that can be shown in different apps. And the signing of transactions and verification of credentials means that, of course, when you're going to take a card, you need to validate your driving license, and this driving license is not anymore limited to one mobility provider, but the verifiable credential is somehow shared in the network. So if you want to rent a car in a company B, you don't need to register your driving license again, as far as you can access to the information that is kept in the mobility provider one. And of course, payment. We are a crypto company, so payment is meant to be done in crypto coins, of course. Where is this connection to crypto? The connection to crypto, meaning cryptographical protocols, is of course through blockchain, and in the blockchain we are trying to solve it in a really clean and light way. So we are aiming to save the less information the better. That means only the identification and verification, rental contracting, and settlement of payments, both B2B and B2C. And yeah, of course, we have our own token, which is going to be launched on the 22nd of this month. The name is BLXM, so it's the bloX.move token. And as you can imagine, is the payment method inside the platform. Apart from that, it can be used also to settle liabilities between the companies that are integrated in the platform. Redemption of mobility service, that means basically the payment that the users need to do for the mobility services. Network security and governance. All of us here are pretty used to these terms and to how this thing works nowadays. So as I said, keep in mind 22nd of October IDO. And yeah, of course, this project is not only a crazy idea. Actually, this project was born inside Daimler. Daimler is the holding company that owns Mercedes-Benz, for example, and so on. And after 3 years of development, the company decided to make a spin-off here, and this is bloX.move. So bloX.move was born inside Daimler, but has no more connections to Daimler anymore. So that's why we are able to grow in different directions. We are able to connect with different partners, as can be shown here. Most of them at the first level, let's say at the action level, are of course crypto developers and people that are trying to build platforms as we are doing, but we also have some pilot already in decision with really important mobility providers as Flixbus, really well-known bus service company in Germany, Athlon mainly for leasing, and BMW, Porsche, and so on and so on, and many others in, let's say, local mobility or electro scooters, bicycles, and these kind of things. So yeah, sorry for this marketing. Until here, I think it's a bit necessary to understand the background. But now we can dive deep a little bit on what the topics bring us here, which is artificial intelligence and cadCAD. I'm going to do a kind of high-level presentation of what artificial intelligence is, or the way we understand artificial intelligence. But again, if something is not clear, please feel free to ask at any point. The formal definition of artificial intelligence is the ability of digital computers to perform tasks commonly associated with intelligent beings. And this term is frequently applied to project development system endowed with intellectual process and so on and so on and so on. Too much blah blah blah. What it's basically saying is that it is something that lives inside a computer, let's say an algorithm, that is able to solve tasks that are similar to the ones that humans solve. That means that is that intelligent, or is just mimicking what humans are doing, and that's why we are saying that. This is something to be discussed. And the scope of application is meant to be multidimensional problems where big amount of data is available. Big amount of data and big amount of good data, because artificial intelligence needs to learn from the data, and if the data is not okay, or if the data does not properly represent the reality that we want to analyze, of course the algorithm and the process are not going to be representative. And actually this is a really important point, because the selection of the use cases is not always correct, especially nowadays where the application of artificial intelligence is not clear in many areas. At my time at Daimler, I was working as a consultant for some AI development, and usually our first advice to anyone that came to us was not to use artificial intelligence. So please rethink your problem, try to find a different solution, try to find a deterministic solution, because it seems kind of easy to say, okay, we can solve this with artificial intelligence, but does it make sense? And to make this analysis, you need to have kind of a lot of knowledge, let's say. And at the end, I make the similarity as when you go to the hospital and you need to go through an OP. It's a solution, but it's a hard solution, and it's not always the best solution. Because at the end, we are just doing some approximation. We are just doing something that tries to fit to a problem based on empirical data, but this is not purely scientific, so it may fail. And as I said, data is the key of everything, and most of the work and most of the effort is on the data and dataset side, cleaning the data, checking data, ordering the data, and so on and so on and so on. And what is artificial intelligence in practice? And this is a little bit own vision that we have, and I would like to say that it's basically a commercial name. It's something that we say that because it is cool and it's a hype now, and even when you're looking for investors or funding, if you put the words artificial intelligence inside, you get a huge push. But actually are empty words, because the algorithms that are behind artificial intelligence are not intelligent at all. They are just powerful tools, that is true, and really useful tools, able to perform analysis and able to find and correlate what they call hidden features. Okay, these hidden features are basically the characteristics of the problem. Why do we say that hidden? Because as I said in the previous slide, artificial intelligence is meant to be applied in multidimensional scenarios and complex problems. So that means that the human brain is not able to analyze 25 different parameters that are affecting a problem at once. So we are not able to recognize these representative characteristics, and artificial intelligence can do that. But be careful, because as I said before, it is not intelligent. It is just a way to leverage the intelligence of the one that is behind it. So it's a way to improve, or a way to be more efficient if you apply it properly. If you do not apply it properly, you are automating and you are leveraging a problem that is going into the wrong direction, and this may cost a lot of effort and problems, mainly because you are not able to recognize that it is going into the wrong direction. And from the formal side, let's say it's based, all of us know that it's based on mathematics, but from the formal side, when we talk about artificial intelligence in these specific application areas, we are talking about machine learning. And what is machine learning? Machine learning, as Andrew Ng defined it, anyone that has any experience or any interest in machine learning has probably come across with this name and this guy, because he's one of the first persons that were trying to apply to in an industrial way and to extend the applicability of machine learning to the real world problems. He was part of the Google Brain team. Actually, I think it was the head of it. And he also created the Coursera platform, where he did not only found it, but he did also actively participate by adding some courses that I can only recommend. There are several courses in machine learning hosted by Andrew Ng that are really, really interesting, and you can really learn a lot of stuff. And what he's basically saying is that it's the science of getting computers to act without being explicitly programmed. And I feel a bit bad to correct him, but I would like to add explicitly programmed for some specific and limited problems. And what does it mean? That means that machine learning is a really powerful tool, but it only works in data, and it only works in the specific case that it has been trained for. So if we train an algorithm to detect wherever, let's say a cup, we are going to train an algorithm that differentiates what is a cup, or maybe a better example, differentiate what a fork is or what a spoon is. It is going to work, and it is not going to work in a deterministic way. So each time or each image that we show of a fork is going to be able to recognize it. But if we show an image of a knife, it is not going to be able to say if it's a fork, if it's a spoon, or if it's something different. And of course, it is not going to be able to say that it is a knife. So without being explicitly programmed, yes, but only in the range where it has been trained for. And if we go to another definition from for example, from Search Enterprise, They are talking about software applications that become more accurate and predict outcomes without being explicitly programmed for. So it's more or less the same as before, but here we have a new interesting topic that it says become more accurate. That means that there is a dynamic inside this algorithm. That means that these algorithms are not static, and that means that these algorithms are able to adapt to new situations. And how is this thing done? Well, this thing is done basically through mathematics and basically through statistics. And I have a small diagram here at the right to show you what supervised learning is, which is kind of the most used machine learning paradigm. There are many more, but this one is the most used, I would say. Basically, what we have is an input, and we throw this input inside the algorithm. The algorithm is usually, and especially for non-experts, is a black box. We throw the input inside, and we are expecting to receive like a really positive and really accurate output. To get that done, of course, we first need to train this machine learning algorithm. And we train it by comparing the output with the output with the real output. So that means that for the input, for the first input that we are giving to the algorithm, we already know, let's say, the classification tag, or we already know what should be predicted. And we compare the actual output with the real output, as it called here, the target. We calculate an error, and then this error function, we send it again to the algorithm, and the internal weights and internal information is adapted. By repeating this process thousands of times, at the end, the error is going to be close to zero. It's going to disappear. So we would say that our algorithm is able to predict correctly, even for images or even for examples or for inputs that he has never seen, as far as he's training for that. Okay, but how can machine learning be used, or what is machine learning used for? Basically, it is used as a data analysis. We are going now a step higher. So we are going not anymore into the technical data. We're just going to say, okay, what are you doing? Okay, you are telling me that this input is A or this input is B, but what are you doing internally? You're doing data analysis. You are extracting some kind of information. You are extracting some kind of these hidden features, and you are directly elaborating a conclusion for them. And this is one of the biggest problems that that machine learning has. One of the biggest advantages and one of the biggest problems. And the problem is that people think that only by throwing data inside, the output is going to be correct and the output is going to solve everything. And they try to apply machine learning end to end from the beginning to the latest stages of the process. And people is I saw something funny here, just putting some random characteristics, and they are going to tell you if it's the man or your life or not. Some applications actually do that if you look for them in your iPhone. But in a realistic way, machine learning is used for autonomous driving, Face ID, GPT-3, which is neural language processing, quality inspection, and so on. So it is useful. It should be used, but it should be used carefully and only in the cases that is interesting and relevant to use it. And once that we understand that machine learning is used to analyze information, we can also think a little bit further and say, okay, and what happens if I try to use machine learning to make decisions? Not only to extract this information, let's say, and to analyze kind of historical data, but to evaluate the decisions that I make based on this historical data. And from a high-level perspective, it's actually the same point of view. You have some information and you extract, you have some data and you extract the information, and here in the decision-making process, you have some actions, and then you analyze what happened after these actions. And this brings us to what reinforcement learning is. Reinforcement learning is another paradigm of machine learning that is basically composed of different machine learning modules that are working one after the other. We have analysis modules. We have analysis modules that map what is happening in the reality, that maps what is happening in the real world. and we have decision-making modules that act based on the result of the analysis. So here you see that we have one machine learning for analysis, one machine learning for the decision-making process. And again, to make it a bit more clear, we can understand reinforcement learning as a fact-driven try and error search. Is brute force, so that means that the algorithm is just trying actions, testing actions in one direction, in other direction, and just checking if the final output is okay or not. The application range of this paradigm, of course, is enormous. But as I said in the first slides about artificial intelligence, it makes sense to use it in complex environments where we cannot understand the hidden features. So let's say multidimensional environments, and especially in dynamic environments. In these environments where the decision-making process depends on the analysis, and the analysis is not static and is not always the same. How it works is very simple. We have a picture here on the left where a dog, let's say the agent, is watching the environment, watching what is happening in the surroundings, and he decides to take an action. Let's say in this case, this girl is throwing a stick, so probably if the dog recognizes that, catches the stick and brings it back, he will get something as a reward. And here is the third function, this reward that we are always going to map in our mathematical model. At the right side, we have a little bit more formal description of the same problem. We have the agent that is acting over the environment, and after acting in this environment, he's able to observe what has happened and what has changed. This observation is represented here by the state, so ST, and also the reward function. Because the agent is motivated by a utility function, the agent is interacting with the environment because he wants to receive something in exchange or to achieve something, and this is represented by the reward function. And this logic or this utility function that drives the behavior of the agent is the policy that appears here in the last line, is the mapping from the perception, let's say from the analysis part, to the action to be taken, let's say to the decision-making process. And yeah, as you can imagine, when we have this integration, let's say, of multiple machine learning algorithms, it is not easy from a software perspective, it is not easy even from a mathematical perspective, but hopefully we have some ecosystems and we have some libraries that helps us to create and develop and play around with these reinforcement learning solutions. And the most known one, I would say, especially for research, is OpenAI Gym, which is a company founded, I think, also by Elon Musk, and basically provides a structure where we can create environments, agent policies, connect them, do the training, tests, and so on and so on. Again, at a high level, and from a general perspective, it is more or less the same as cadCAD. cadCAD is a platform that provides you with a template where you can define your agents, you can define your environment, and you can define how the environment is behaving, and make some simulations, make some dynamic simulations, and see what happens. The only difference here is that in cadCAD, cadCAD is focused on generating the data, and OpenAI is focused in analyzing the data. Brings us to the last part, where this integration between cadCAD and reinforcement learning comes into play, because, as I said, most of the things that are existing in reinforcement learning are already existing in cadCAD. So the merge of these two ecosystems, from our perspective, also from the beginning, made a lot of sense. cadCAD, I cannot tell that much, even here with people that has developed the platform. So as you know, it's an open source package that allows you to create complex systems and allows you to analyze the interactions between multiple agents and these environments. In the case that we were working for in this research group, we were working with balancer liquidity pools, and we were analyzing different token combinations, number of pools, kind of agents, investors, and so on and so on and so on. But at the end, the most relevant thing in this combination and the role that cadCAD is playing in this combination with reinforcement learning is the data generator. And for that is a really, really helpful tool because it allows to create an unlimited amount of data. I've been talking through my whole presentation that the main or the most important thing when we're talking about artificial intelligence or when we're talking about machine learning is data. And data, not only good data, but also in big enough amounts of data, which is actually in the reality a problem. And having something that allows you to create this synthetic data, to generate this synthetic data in a limited amount is something that is really, really helpful. So how can we merge these two technologies together? So of course, as I said, we can generate a lot of data and we can just process this data. This is kind of historical analysis, right? Because they are kind of disconnected in the way that the machine learning algorithm, the machine learning analysis tools are not running during the cadCAD simulation. So we generate a package of data and then we pass it through different algorithms that can be decision trees, can be temporal series, convolution neural networks, recurrent neural networks, clustering algorithms, wherever. But the point here is that this is kind of historic analysis. So we can only analyze what have passed in the past. But all the time we've been talking about agents and we've been talking about the interaction between these agents. So if what I want to model is a new agent, if I want to analyze how an agent is behaving in our environment, it's of course relevant and it's actually a must to analyze how the behavior of this agent affects into the environment. So we can assume that the number of agents is that big that me as an agent has no influence in the environment. Okay, in some specific use cases that could be right, and then this kind of analysis works. But if I have some influence in the overall ecosystem, this kind of analysis is limited because I cannot analyze my influence on it. And to do so, what I need to do is use reinforcement learning, because as I said, reinforcement learning is meant for dynamic environments where I can learn, where I can observe what is happening, act on it, and also evaluate my actions there. And here we have the same diagram as before, the formal description of reinforcement learning, where we just need to change the environment that we were using before for the cadCAD environment. So it really makes sense. We have an agent, we connect it to cadCAD, it acts as the test environment, and we are able to read the new states, we are able to calculate the new function, and I'm able to train my agent in this situation. So from the general perspective, from the schematic perspective, it makes a lot of sense. We can also see it in the other way around. We can also see it, and I'm talking now about the image that we have on the right. We can just see that cadCAD has a lot of agents acting in his system, and one of them is intelligent, right? It's driven by a reinforcement learning algorithm, and it is acting and adapting dynamically to it. What's the problem here? The problem here is that in the last slide of the last section, I was saying that cadCAD and Gym AI were similar because both of them are platforms, and of course both of them has a specific architecture, and both of them has been designed to be used end to end, and they has not been designed to be merged or to be integrated in other platforms. So for example, if we look at the left, where cadCAD exists in Gym, and I'm talking about software integration, architectural software integration, we have in the reinforcement learning description, we have policies, we have actions, and we have rewards. This represents more or less the agent. And then we have the environment. And the environment could be a cadCAD environment. The problem is that in OpenAI, the way that the environment should be described is through these three different functions here, which are init, step, and reset. That as far as we are doing some training and as far as reinforcement learning is some try and error, at the beginning random, and if it is not learning at all, it's going to be a random try and error for a long time. We need to prevent like infinite loops, and that's why we have this reset function. However, this step function is pretty similar to what cadCAD is doing. They have like a watch, and we have this parcel step updates function and so on. So could be somehow match. However, from the software perspective again, and the integration and the way that cadCAD divides the file and the callings and the functions, internal functions, it's a bit tricky to do that part. And we have done some tries, we have achieved at some points, but it's really slow and it brings a lot of errors. On the other side, if we just want to implement the agent in cadCAD, this is much easier because, as I said, cadCAD already has this function or this gap to implement the agents inside, and then the final solution should be something like this. We have the cadCAD, and in the agents file, agents.py file, we only need to put inside the reinforcement learning code, the reinforcement learning calls to the libraries that we have before. And in this way, we can create an algorithm that is learning, that is acting, and that is adapting dynamically to what is changing in the environment. And here, if we go a little bit into the code, these are some snippets of GMAI. So as you can see here, you can believe me or not, but this is everything you need to create a reinforcement learning solution, starting from the right to the left. At the right, we have the environment description, and the way we define the environment, we need to define the environment through the dynamics of it. So we need to define the environment based on the actions of all the agents and based on how this environment is evolving based on these actions. We also need to define the reward function. We also need to calculate that, and we also need to do the reset check. So to check if we are in a prohibited situation or if we have reached some limit and so on. And this is done here in this code that is 75 lines, more or less. Of course, could be a bit longer, could be a bit easier, a bit shorter, but from a formal perspective and source perspective, it's not a big problem. Where the problem is in the reward function, because the reward function, we may think of it as a function that say, yeah, okay, I just want to focus on this parameter and make this parameter grow, but it is not as easy as saying, okay, if this parameter is bigger than before, just give me a positive, an extra point, let's say, and if it's smaller, just give me a negative point, because there are many factors. Remember that we are in a multidimensional environment, so there are many factors that are affecting, and there are many ways in which this reward function can go up and go down, but on the other side can be somehow prejudicial, have negative influences. And in the middle, we have the training the training loop. So basically, we just need to initiate the environment. We just need to define the policy. Remember, the policy is how the agent is mapping from observation to action. Hopefully, there are there is a wide catalog of policies that can be used depending on the kind of on the type of environment we're moving on. And here you just see one line. I'm talking about the line number 10, where we say model equal to PPO ML policy, environment. This PPO function here is a whole library. I don't know, I've been working with it now for 2 years, and I do not fully understand all of the code here. So it's really huge software behind here. But as I said, hopefully OpenGym has this possibility to just call it and that's all. And then we have the training loop, which is basically called the learning function. Again, the learning function here and all the software behind is huge, but hopefully we can just call it. And at the end, we just need to save the model. If we want to use it, we go to the snippet on the left, and we just initiate the model. Okay, this is my model. This is PPO policy, and I'm going to load the weights. I'm going to load the model that I've pre-trained, and I just use it. I have some observations. I give these observations to the model, and the model is give me the action that I should perform. So, what is our vision here? The integration we have already talked that this can be a bit tricky depending on how to do it, but it is possible to do it. The problem is that as the connection and as the integration is not optimized, and both libraries are not designed to be optimized, the final code is not smooth at all. The final code is not optimized at all, and the final code really requires a lot of time. So, one, let's say, best practice or common practice in the artificial intelligence world or in the machine learning world is to do some pre-training. That means that we take our agent, we define the policy, the structure of the policy that we want to use, and we train it a little bit in some toy scenario outside any complex environment. So it learns the basic behavior, and then we connect it to the platform. And this is basically what we want to do. What we want to do is a two-step template. The first one is create this toy scenario where we can pre-train the models. And then secondly is connect this agent that is pre-trained. Of course, it is not fully trained. It is not working 100% correct. It needs to train in the real scenario with the real dynamics of the specific scenario, but it's not starting from zero. It's not starting from scratch. It starts from a minimum knowledge. And the second part of our vision is, of course, an ad list. An ad list that I think is really common to the one introduced by Token Spice, where you can easily define the agent. Okay, I want to define 3 different agents, and this is the actions. Actions means what the agent can do, the reward or the utility function that drives the logic of this agent, and the policy, which again can be selected in a catalog from OpenAI. And still we have some problems, because all these simulations and all this integration makes sense if the data we're working with is realistic. It only makes sense if the agent, not only our agent, but the agents from which our agent is learning from are realistic as well. So that means that we will probably need much more than one reinforcement learning agent, but several of them acting in a similar way as they would do in the real world. And until now, we have been talking only about one agent, and I've talked about problems as time cost, computational power, complexity in the description of the functions, and so on and so on. And this was only for one. If you need to combine the training of several agents, if you need to combine the training of 100 agents, this is simply impossible right now. So which are the solutions? The solutions are independent pre-training. It is not the same training 100 agents from scratch that training 100 agents that are at 80-85% of the capabilities and just need to fine-tunes the final stage of their behavior. Aggregation in terms of how can I benefit from the work that other people is doing, and this goes into the direction of a community, this goes into the direction of a catalog of trained agents for specific behaviors. And the last one is the abstraction. And abstraction, I will try to be short here. Abstraction is the process of getting general rules from specific examples. Could be defined something like this, and it is usually applied to data. It is usually applied to specific problems, but the idea that I want you to take home today is that these general rules, these general characteristics, does not only exist inside one specific problem. These general rules and general characteristics exist also among different problems. And why this is important? This is important because we are talking all the time about mathematics. We are talking about how to mathematically represent a reward function. But when you go into the mathematics, a reward function is usually a factor. Let's say 4 times characteristic A plus 3 times characteristic B plus 2. And these numbers, these 4, 3, and 2, are the ones that are adapted and are the ones that needs to be fine-tuned during the training. But the characteristics that you put inside can be anything you want. And if you are able to define a reward function that represents more than one behavior, this agent that you have trained only for one behavior can be directly exportable to other solutions. So this is reducing the amount of time, this is reducing the effort that you need to put into the development and into the training of the agents. Of course, this is keeping people away from artificial intelligence and from machine learning, because I start saying that people think that artificial intelligence is an end-to-end solution, so I just give raw data and I directly get some magic happens and I directly get the conclusion that I want. And it is not like that. And what I'm saying here now is, please still put more work on the data before. Please put more work on your problem. Try to understand your problem. Try to find similarities between problem A and problem B. Because if you put enough work and enough effort there, you may find the solution. You may find the way to solve both problems with only one artificial intelligence solution. And this is the key for scalability, and this is the key to really make these realistic solutions and be able to extract meaningful knowledge out of that. So just a quick summary of the limitations of reinforcement learning. Heavy computational cost, time, and remember, success in machine learning is never guaranteed. Remember one of the first slides, if you automate a positive process, you are going to leverage it in a positive way. If you automate a process that is driving you in the wrong direction, you are going to go into the wrong direction much faster, and then you're not going to be able to recover. And the best practice, keep it simple. Try to benefit from the work that other people is doing, and try to benefit from the work that you have been done by adapting it to new situations or by making it adaptable to future scenarios. And yeah, a final summary. I hope you are still, you did not fall asleep. A final summary of what we've done today. We've done a little bit about artificial intelligence. I have explained the difference between artificial intelligence and machine learning, and especially with reinforcement learning. I have explained why there is a synergy between cadCAD and reinforcement learning. cadCAD as data generator, unlimited data generator, and reinforcement learning as analysis and decision making tool. And we have discussed a little bit the architecture integration. And yeah, and on the limitation side, of course, time and effort, and reinforcement learning is not locally scalable. It's not locally scalable. We need a lot of hardware power. We need to be intelligent when using it, because if not, we're going to die. And there is further work on our side to do, and we are developing improving the platform, let's say. We are optimizing the code, we are optimizing the integration between cadCAD and reinforcement learning. And we are creating in our local system, in our local servers, a community of trained agents that we are trying to use and reuse from one scenario to the other. But of course, the vision for the future would be to expand this community and create a general community with all the people interested in token engineering, all the people interested in cadCAD could create their own agents and share them somehow, and that can be plug and play in different environments. So anyone that wants to create some solution does not need to start from zero, but could start from the work that previous people has done until here. And yeah, this is all on my side. I hope it was interesting. And if you have any questions, feel free to bring them to the table now or reach me in any of the channels that are running there. You have my Twitter account, Discord account, and so on and so on.
Awesome. Thank you, Daniel. That was awesome. And so I noticed we are at the top of the hour, but I feel like this group definitely has a question or two. So Daniel, if it's all right for you to stay an extra few minutes, maybe we can do a few questions. That'd be awesome.
I just need some water and yeah,
cool.
Go ahead.
Yeah. All right. Take a breath and drink some water. And anybody who does have to run, thanks a lot for joining. And the recording will be posted afterwards too, so you won't miss the questions if you do have to go. But otherwise, please ask away. I'm sure there's a few floating in the audience.
Hey, hi Daniel. Can I ask a question?
Yeah, sure. Go ahead.
Yeah, really exciting presentation. Really well done. Good work. I like the way you laid it out.
Thank you.
I'm wondering, is this on what spectrum of this, or the spectrum of sort of research and industry application is this? Like in terms of bloX.move, are you using this directly in the optimizations of the system or in the simulations of the system, or do you see this more as being a research focus and having some ways to go towards being directly applicable?
Yeah, good question. Actually, one of the best practice, as I think I mentioned a couple of times during the presentation, when you're working with machine learning or artificial intelligence solution, is you need to first make sure that your solution works. So you need to create like a toy example and test your algorithm in this really toy example and say, okay, this algorithm is able to solve it. So the scope here, the scope that we, or the project that we approached in the token engineering group was to create some kind of trading boot, some arbitrage between two pools. So it's clear that the agent, when doing this arbitrage between liquidity pools, has some influence in the ecosystem, and it should learn how to do that. This was just for research purposes. Of course, this is kind of trading and so on, and we are not into these things. This is just a toy example to demonstrate and to try to check if it was possible to merge cadCAD and reinforcement learning. The way we are going to use it in the company, the way we are using it inside the company, is more at the analysis level, is more at the macroeconomic level. What is going to happen when we vest tokens here, here, or here, which is the best periods of time along, I don't know, several years. So it's more into the macroeconomics. What is going to happen if the fees in the protocol are this? What is going to happen if the number of users decrease or goes into this direction or into the other direction?
Awesome. Thank you, Daniel.
Yep.
And I actually have a question too. You mentioned at the end that it would be awesome if people were able to build agents or tools like you've been working on in a way that's modular and scalable, so everyone can pick it up and not have to start from scratch. Is any of the work that you've done, are you planning to make it, I don't know, open source, or would you be able to offer it up for people to use as like a starting point for their own reinforcement learning agent projects?
Of course, if you ask me, the way I see it, our main contribution here is the analysis of the integration of these two platforms. The agents that we have trained, I think they are already in GitHub. This platform is, most of the code is already in GitHub. We share it, I think, at the end of July, and can be accessed from some token engineering documents. Angela, correct me if wrong. And
yeah, it's available. We can share the links later.
Yeah. And the agents and the trained agents are there or should be there as well. So let's say this information. The problem is that, as I said before, this is a toy example. So anyone can use it as a baseline, anyone can use the platform, anyone can use the agents. So these agents are not fully operational or are not 100% intelligent at the level that they should be. So of course, anything we do, and whenever our new version and new status is ready, we are going to share it through the channels, through the typical channels, and share it also with the token engineering community. Yeah.
Cool. Yeah, I'll grab some of those links then. We can resurface them in the call notes and stuff. All right. Any other questions?
Thank you very much for all of this and all the work you put into it. I appreciate it. But yeah, I'm gonna go. But again, thank you very much. This was fun.
Thank you for attending, and if you have any questions at any time, feel free to reach me.
Thank you. You guys, everybody have a great day.
Yeah, see ya.
Bye.
Ciao.
Thank you, Daniel, Peter, Angela.
Yeah, thank you all for joining.
Gotta go.
Thanks,
Yeah,
everyone. See you.
All right.
Thanks.
Drop it out. Cool. Yeah, thanks for joining, everyone. And Daniel, thanks for the awesome presentation. I also learned a ton, as Jake was saying, so appreciate it.
I
Daniel,
hope so.
thanks so much. And let's stay in touch, right? So maybe 6 years down the road, there might be updates.
Yes, definitely. Oh, I have.
And the token launch.
I have. Yeah, token launch 22nd of this month. Really, really important. But
Yeah.
most important for you, Angela. I think I still owe you some feedback on the message you sent me. I didn't answer. I was so busy. Sorry. I'll do it.
Still relevant. So
Okay,
feel free
yeah.
to type some words.
Yeah.
That's
Always.
why she showed up today,
Thanks.
to make sure you replied.
Yeah.
All right.
I promise you are still recording, right? I promise that tomorrow you will have an answer from my side. Yeah.
All right. We got
Okay.
Okay. Thank you very much
All right.
for inviting us to the community, to giving
Yeah.
us this opportunity to share not only the research but also a little bit of our company. And as I said, really happy to collaborate with you all, and also with any other person that is interested in reinforcement learning, in cadCAD, and of course also in our project.
Yeah. No. Really.
Thanks.
Really cool application.
Yeah, I was really excited for this talk, Daniel. I'm the executive director for the cadCAD Foundation and product manager at Block.Science Labs. So I will be in touch with you.
Definitely. My user is here, dr10 bloX.move. And yeah, as I said, we are really happy to collaborate in an open source community and an open source way.
Cool.
All right.
Yeah, we're happy to have you.
Take care, everyone.
Yeah,
See you, Chris.
thank you very much.
Thanks a lot. Bye.
Bye,
Ciao,
everyone.
ciao. Ciao.